Okay, hi, my name is Sapir. I know it's hard to pronounce, so it's Sapir. I'm going to present a tool I developed that's supposed to help to perform incident response in Azure Active Directory. So a bit about me. I live in Tel Aviv, Israel. I have a bachelor degree in computer science. I spent a bit over 4 years in the Israeli Air Force as a security researcher. So I know when I say army, so people may think some weird stuff. So this is a picture of me with M16 and a ukulele. I don't know how to use either of them, okay? So my army service looked more like this, okay? Except I didn't have a flying computer. But apparently, when you ask Midjourney to give you a female programmer picture, he thinks that's some sort of a fiction situation, hence the flying computer. For the last 1 year, I'm working for Semperis as a security researcher. In my free time, I love to develop some stuff, so I wrote one AAD internals function, which is probably one of the proudest moments of my life. I developed an Android application, some simple neural network models, and a ChatGPT plugin, and Reportly, which is the tool that I'm presenting to you today. So I start by talking about an SMTP or soft match abuse that I discovered a year ago. Then we talk about incident response in Azure AD and why it's a bit problematic these days. Later we go to Reportly, we talk about the tool, we see some examples, and we'll try to solve the soft match abuse using one of the reports. Then we talk a bit about the future features of the tool, and hopefully some questions. So just a few words about the soft match or SMTP match process. So this is basically a synchronization process in hybrid environments. In this process, we're taking an existing Azure Active Directory user, and we create a new on-prem user, and we just want to sync the on-prem one into the Azure one. We do it using 2 attributes called user principal name and proxy address. So basically, that's it for the synchronization process. So this is a synchronized user page in Azure Active Directory. So you can see in the on-premises section, there is the on-premises user principal name, which in this case is Alex W. And this is exactly the same as the user principal name in Azure. But here the suffix of the user would be the on-premise domain, and in Azure it would be the Azure tenant. So this is the first attribute that I talked about, the user principal name. We need it to be identical for the sync process to happen. And the other attribute is the proxy address. So this is basically like the email address of the user with SMTP prefix. And this is the second attribute we need to be matched in order to do the SMTP match process. So this is the user principal name, as I mentioned before. So this is the exact same user, but on-prem. So we can see the user principal name with the domain suffix and the proxy address, which is identical. And once we create this user with this attribute configured, this user will synchronize into the Azure one. So that was the first part we needed for the abuse. And the second part is eligible role assignment. So a user in Azure can have 2 kinds of role assignments, active and eligible. So active is just active. This user has these permissions. And eligible, it's basically supposed to be more secure, because this is a way to temporarily elevate the user's privileges, so the user can activate the role if he needs this, the permission that this role is supplied. So how a user can activate its role? You need to authenticate into its Azure AD account, go into PIM, which is Privileged Identity Management, and just click Activate on the role that he wants to activate. Important thing here, some of the roles require the MFA to be activated, so this is something that we should probably remember for the abuse. So recap about everything. SMTP match or soft match is a process where we're taking an existing Azure user, create new AD user, performing the sync using the user principal name and proxy address attributes. Once it happens, important thing is that the Azure Active Directory user's password is going to be overwritten by the AD user's password. So basically, they're going to have the same password, which is the whole basic for our abuse. So the important thing that we need to talk about is MFA, because if there is is MFA configured for the Azure user. So even that we now know its password because we synchronized it from the on-prem, we don't have its MFA, so we can't immediately compromise it. So this is one example to know why MFA is so important. Another side note is that you can't synchronize yourself from on-prem into a high-privileged Azure user. You can do it because Dirk Jan reported it in 2018, and Microsoft fixed it. So this what would happen if you try to do it now. So if I have Patty here, which is a global administrator, let's say, and I'm creating a new on-prem user with the same user principal name and the same proxy address. So basically what will happen is that we just create a new synchronized user, which is similar to Patty, but it's not Patty, it's a different one, and is obviously not high privileged, so it doesn't work anymore. This is the Dirk Jan presentation from Troopers 2018 when he told about this abuse. So what's my abuse? My abuse is basically a bypass to the original abuse. So instead to try to sync ourselves into high-privileged Azure user, we will sync ourselves into an Azure user that is eligible to high-privileged role because Microsoft didn't fix this issue. So it's still possible. All you need to do is to find an Azure AD user that is not synchronized already and is eligible to high-privileged role. Then we will create the on-prem user with the identical proxy address and user principal name. Then one sync process will happen. We will override this user's password. Then we can log in as this user if it doesn't have MFA configured and activate our role. So that's great. Let's say now that we're working in a company and we have an on-prem environment, and now we want to move into a hybrid organization. So we created an Azure tenant, and now we have a hybrid organization. And we have this malicious actor who compromised the on-prem environment a long time ago, but now we want access to our cloud resources. So we decided to implement my abuse, as it's still applicable, and he compromised an Azure AD user, which is eligible to high-privileged role. He activated the role, he accessed some cloud resources, and then the SOC team noticed that something is wrong. So they called the IR guy, which is us. As you can see, we are very motivated, and we are happy to help, and we really want to start the investigation. So let's start it. So we know this is the suspicious user because the SOC team detected it. So what can we do? So first we can start by just learning some information about this user. Then we should probably go to the audit log, so we will talk about it in a minute. Obviously, same for the sign-in logs. So we have the roles, the groups, applications, devices, authentication methods. So each of them is on a obviously different page. For each group, might be interesting to check the roles, the owners, the members. And for the audit logs, the best part is that we have 3 tabs for each log, because it's just not enough torture to scroll these logs. So we have the activity tab, and then the targets tab, and the modified tab. And we're going to do it for each of our 10 or 1,000 logs. So not that motivated anymore. More logs, always fun. So I think we understood the problem by now. So there is no convenient way to understand what a user done over time. Just very difficult. Also, I know I've been there. I don't know how many of you did incident response before, but after scrolling logs for a while, your eyes start burning, and also you just realize that you're staring the logs for like 2 hours now, and you really missed half of the information. Also, the general information about the users, the roles, the applications, everything is scattered in many different pages, so it's very easy to miss a lot of important information, and it might supply an interesting lead for the investigation. And my favorite part is that the authentication log and the sign-in logs are on 2 different pages. So if you want to know what user did since he logged in, you need to try to take the 2 pages and correlate between them somehow. So this is very fun. So this is part or most of the reasons that made me feel like I need to create a more easier or comfortable solution to perform a normal incident response, or even just a first investigation to understand who is this user and what he did in a given range of time. And this is why I created Reportly, which is the tool we're going to talk about. So I don't want to talk a lot about the tool. I want to show it. So we'll start by looking at an example report. So this is just a normal report. It doesn't contain any attack or something, but I just want to see what information we can get from it. So we can see here some information about the user principal name, when it was created. If the user is synchronized, we will see the on-premises seed and user principal name. Then we have the groups tab. So for each group this user is a member of, we can see some information, and if the group has some roles, we will be able to see it too. Then we have two tabs for the user roles. So we have the eligible tab and the active roles tab. Then we have the owned object tab. So owned object is basically groups, applications, and service principal. If they have high privileges, so we will be able to see it in here too. Also on devices tab. Might be useful sometimes, maybe even just to get some leads. So maybe we see a new device that was registered. Then we have tree graph. So the first graph is for initiated activities. So we can see here the activities that this user performed in the given range of time. So if we hover over each activity, we can see some information about it. So for example, this one is add user. So we can see the name of the user that our user added. And there is a different information for different activities. So here there is the add eligible member to role. So we can see the member and the role. So different information for different activities. This graph is basically the same. We can hover over the activities, but the difference is that this is activities that were performed on this user. So this user is the target of these activities. Although, in some cases, it might also be the initiator of them. We will be able to see it in the initiated by part. So for example, here in the update user activity, we can see that this user is the initiator and the target of the activity. So it makes sense, because sometimes maybe I want to update some information about myself, so might be the case. And the last graph is for signing. So we can play, oh, wait, important, okay. So we can play with the login status. So we can check the failed and the successful logins. So for each failed login, we can have the error code, the reason, application that was used, time. You can see all the information here. We can also get closer, so just to make sure that we're not missing any important information. Same for the successful logs. So we can see the resource that this user authenticated to, the status, time, all of this stuff. Then here we have some IP information. So for each IP that this user used in the sign-in graph, we will be able to see geolocation, the application it was used, the amount of times this user used this IP, resources. And this tab, the suspicious failed login tab, so it's supposed to help us to highlight stuff that we might miss in the signing graph, because it still might be confusing, and maybe we don't want to go for like each event in the graph. So this is just a static list of failed logins event that might be more interesting, in my opinion. So they just might to help you find some more leads. And first and last thing is the MFA information. So if the user registered some MFA, we can see it in here too. So it also might be useful. So this was an example report. So what we can learn from it, so there is kind of user-friendly interface, more easier overview of this user, so everything is in one page, so it's kind of convenient. There is the timeline, which might be very helpful when you try to understand like a flow of attack. And we have the suspicious events that might help us find some more leads for further investigation. So now we will talk about a very small privilege escalation, and we see how it looks on the report. So this is the application administrator into global administrator privilege escalation, so it's very basic. So application administrator can take any app and add permissions to it. So for example, here I added the administrative unit read all permission, but application administrator can't grant admin consent to this permission. So it can't really act on behalf of the application with this permission, because he didn't really granted them to the app. But what he can do is to find an existing app that already consented by a global administrator with the required permissions, and just add a secret to it. And once he added the secret to it, he can just act as this application, and that's how we escalate privileges. So we can see an example report for this scenario. Okay, so we have a user called app admin. If we go to the roles, we can see that he is an application administrator. So if we go into the initiated activities graph, so the first thing that I immediately see is this failed event. So we can see there is a consent to application failed event. We can see the name of the application is test44. And just a bit before that, we can see 2 update events for this application. So might be the case that this user tried to give permissions to the app, and this is the update activity. And then he tried here to grant admin consent and failed. And a moment later, we can see these 3 successful events for a different app called Hypriv app. So I guess not every time the app name would be so helpful, and we probably will need to go and see which app it is. But the first event I'm seeing here is the update application certificates and secret management. So basically, we can assume that this user added a secret to this new application after he failed to grant admin consent to the other application. So this is kind of good lead to guess this was the privilege escalation. So this is basically this is it. But if we keep scrolling down, we can see a bunch of Fed logins here. So if we go to the suspicious Fed login tab, we can see there is some suspicious or like more interesting error. So the account is locked because too many times this user tried to sign in with the incorrect user or password. So this can be helpful too, because if we know this user done like malicious activity, maybe he got compromised, and maybe he got compromised as a result of brute force. So this might help us to get some leads. Also, we can see the successful login event 10 minutes after the account was locked, and this is exactly a minute before the attack flow started. So might be helpful too. Okay, so we saw an example report. We saw a report that solved simple privilege escalation, and now we will look at report and try to understand the abuse I talked about in the beginning of the talk. So I'm just doing a recap about the steps that require to implement it. So we need to find Azure Active Directory user that is not synchronized and eligible to high privileged role. Then we're going to create on-prem user with a correlating proxy address and user principal name. Then when sync process will happen, we will override the Azure user password, log in as this user, and activate our high privileged role. So let's see what we can see in the report. So we can see we have a report here for a user called the almost admin. We can see this user is eligible to application administrator role. Also, under the on-premises, we can see that this user is synchronized. But after the attack is implemented, this user is supposed to be synchronized. So this supports the scenario that we are talking about. So if we go into the activities as target, so there is a couple of interesting things here. So first thing is the change user password. So user's password can change, and it's not always suspicious. But what's interesting here is the initiator of this activity, which is the sync account. So the sync account is responsible for the synchronization process. So this is changing the whole picture, because now we know that this user's password was changed as a result of the synchronization process. So that might give us a big lead of the fact that this user might be compromised using the on-prem account. Also, we know who is the on-prem account because we have its user principal name and seed here under the on-premise information. So this is the first thing we see. We can see here a couple of more update activities related to the sync account. So might be helpful to understand this was like initial sync and not just a password changing sync, although it's not certain and definitely need to it's just a lead. We do need to do further investigation here. But then we see these events for role activation using PIM, which support the exact steps that require to implement the abuse. So we can see that after this user's password was changed, as a result of the synchronization process, this user activated its high privileged role that he was eligible to. So if we go back to our abuse, we see that it supports the steps that we talked about. So we have a Azure user that is eligible to high privileged role. We know it was synced, and we know that its password was overwritten, and then he activated its role. So basically, might be helpful, and we might say, okay, this might be the case. Now we can go on-prem, look at the on-prem user. Maybe he did some suspicious things. So that might be a good lead. So a bit about the future features of the tool. So I'm planning to highlight more suspicious events because I think it might be very helpful. Not only failed login events, but activities in general. If you have some suggestions or think the events that you think that are more interesting, you are more than welcome to suggest them. I want to give a lot more information about the user, so when it was last synchronized, when he registered its MFA, and stuff like this. I am planning to develop more convenient way to authenticate when using Reportly, so I didn't mention it yet. There is a video and an explanation in my GitHub page to how to use the tool, but basically for now you need to create an Azure application and assign it read permissions and then authenticate it using this application. So I am going to change it, and you just will need username and password, and that's it. I am planning to improving the visual interface, so not everyone is a fan of HTML reports, so probably will be different formats and other stuff. And I want to support additional events. So what am I talking about? As you saw, for each activities, there is different information when we hover over the activities. So behind the scenes, it's translated into a parser, a unique parser for each activity. So for now, the tool supports a lot of activities, but not all of them. And I want it to be as useful as it can be. So I am planning to create more and more parser to support all the activities that we can. So Reportly will be available on this GitHub page. There is a video explained how to use it, and also a written guide. It's very easy. You just need to give it a user that you want, that is your suspicious user, and the range of time, and that's it. It just generates your report. So for now, there is a POC version of it. I am going to upload in the this week the full version, and I would be really happy if you find this tool useful, and if you have some more suggestions, you want to do some pull requests, you have some improvement ideas, I would be very happy if you write them to me. And that's it.
All right, thank you very much. Any questions? Yes.
First one is for you. So did so which bet did you lose?
Sorry?
Did you lose a bet?
I lost a number of times. I got asked this question.
Okay. Yeah. So anyways, a question for you, and thanks for great presentation. And I assume that you are now getting logs from audit logs and signing logs, but not from Azure log sources, I suppose. But
yeah.
yeah. So
oh no, I am reading I'm reading the activity log and the signing log.
Yeah.
Yes. Okay.
But Microsoft announced earlier this year that they are going to publish a new log source called Graph API Activity Log.
Yeah.
So do you have any plans to use that in the future?
Yeah, definitely. I would really like to create interesting solutions, or maybe detecting some interesting Graph API calls and highlight the suspicious ones. So that might be crazy. I hope I will have the time to implement it. But yeah.
Yes. Hello, thank you. Nice, interesting talk. So I have some more of a curiosity about like the future about like highlighting like events. Do you think about like devising some heuristics because you have like an algorithm that has said, oh, wait, this is suspicious, or do you want more on the? I mean, since we did the machine learning talk, I mean, did you like were thinking about like fitting some model about the data that you have, or just doing like an heuristics that can be still like already super good?
Okay, so at the beginning, when I started to develop the tool, I tried to create some interesting statistic, and I was thinking about maybe implement some simple machine learning algorithm to detect some maybe very specific things. So then I realized that I really liked the machine learning field, and I also took some courses in it, but I'm not an expert of this field, and I didn't want to give wrong information. So a lot of people don't know that this is just statistics. So that's why I go for the static list, because, yeah. But if I knew how to do it, I would definitely implement it. Yeah.
Any more questions? Okay, then thank you very much again, Sapir.
Thank you.